Hey, what's up guys? My name's Lucas, and in today's video, I'm going to be going over the cost of my combat robots. So recently I was a little bit curious as to how much my combat robots cost, so I added it all up to find out exactly how much they were, and I figured it'd make a great video to share with you guys that will hopefully give you guys some educational information and maybe a little bit of advice on what you can do to save money with your combat robots. So I'm going to be going over my plastic ant, my ant, and my Beetleweight combat robot, showing you guys exactly how much they cost, and then I'm going to give you guys a little bit of advice as to what I have done to save money and what I think works and what doesn't. So without further ado, let's get into the video. Alright, so before we jump into how much my robots actually cost, here's some factors to consider when you're trying to kind of decide what maybe your budget should be when you're building a robot. So biggest thing is the weight class. A heavier weight class robot is going to cost a lot more than a lighter one. Pretty self-explanatory. You got bigger parts, more material, all that good stuff. Second thing is complexity. The more features, functions your robot has, the more it's going to cost because you're going to need more different parts. Next, materials that you use. Say for example you're using a lot of titanium and carbon fiber rather than like aluminum, that material cost is going to be a lot more and your robot's going to cost a lot more. Same thing with electronics you use. You could buy a $5 drive motor or a $50 drive motor for an Antweight, and that's obviously going to affect the price of your robot when it is all added up at the end. And then lastly, where you buy your parts. So this is a pretty important point. There's a lot of places you can buy parts at, and not all of them have the same prices. There's definitely benefits to shopping at different websites and stores, but that is going to affect your final price for your robot. All right, let's get started first on my plastic Antweight Sternbach. So it's a if you guys don't know, a plastic Antweight is a 1 pound combat robot that is fully 3D printed. Now, the materials you can use kind of vary. Most of the time, it's going to be materials like PLA+, but some competitions allow other materials like TPU. But it's generally a great beginner class because it's a lot easier to build than a full combat ant. It's a good size of robot to get started on, and the material costs are a lot less than some other weight classes, and in this weight class there's generally a lot less damage done because the weapons aren't as powerful, and that leads to the damage that you do take being less expensive. Alright, let's take a look at my plastic Antweight Sternbach and what it costs. So I have all the whole bill of materials kind of laid out right here, everything I used. I'm not going to go too in-depth into it, but this was a robot where I did actually save a lot of money by buying less expensive parts, particularly for the drive and weapon motors. So the drive motors were only $9 a piece, and the weapon motor was less than $5. And both of these I got from AliExpress. I'll talk more about saving money on motors in a little bit, but this actually ended up working really well, and those motors that I have do function pretty good in this robot. I'll talk more about this later as well, but you can see I did spend a little bit more on the drive electronics for the drive and weapon. Wanted to make sure that I had solid control system so I wouldn't be getting a lot of issues there. Other than that, you can see here this filament cost right here. This is in grams of how many grams of filament I used, and then cost per gram here. And as you can see here, in total about $13. That's going to be a lot cheaper than a full combat Antweight, which we'll look at here in a little bit. But overall cost of this robot was just over $100, which is, I'd say, pretty mid-range for this weight class. And yeah, that's about all for Sternbach. Alright, so like I said, Sternbach costing about $100, And I'd say a good cost range for a plastic ant, what you should be kind of shooting for, is $75 to $200. $200 would be kind of high for a plastic Antweight in my opinion, but that is kind of a range there. So one thing I should mention is these costs do not include things like the transmitter, battery, extra batteries, and battery charger. This is only the robot itself. So when you're actually getting started, you're gonna have to buy additional items. So if you already have access to a 3D printer, when you build your first plastic Antweight, and if you have to buy everything for it, I'd say you'd be looking at spending around $200 to $250. Would be very reasonable to just get started. So a very inexpensive weight class to get started in, a lot less than other ones, that's for sure. All right, now let's move on to my Antweight overdraft. So full combat Antweights are just plastic Antweights, except you can use any type of material you want. So this obviously includes things like metal, different types of plastics, composites, things like that. So you really have a lot more options. Now this is also a great beginner class, but you have to keep in mind that it's going to be more destructive, so your robot is more likely to suffer more damage. But I do think they're more fun to build. You have more design freedom, and you can try different things that you aren't allowed to do in the plastic ant class. But on top of all that, it is more expensive to build these things because the material costs go up as you have to purchase things like metal and different types of plastics, things like that. All right, so here is the list of parts for overdraft, which is my Antweight. It is a shuffling overhead spinner. So this is a pretty complicated robot, and it's going to it has a lot more parts than most robots do. So looking down here, for drive motors, I did go for a little bit more expensive motors here. These are the Repeat Robotics 16mm motors, and they work really well, which, I mean, spending the extra money here on drive motors has given me some benefit as opposed to kind of skimping out and going cheaper, but it's pretty expensive though, almost $38 for 2 motors. It's kind of a lot, especially if they break. But other than that, I actually did try to spend a little bit more money here to buy better quality parts. So we got rather expensive servos, using pretty much the same drive electronics here as my plastic Antweight. A lot of the electronics are very similar, which is one thing between plastic ants and ants that's going to be the same is the electronics are going to be almost identical. A little bit more expense here on things like the batteries, and then there's just a lot more miscellaneous things like hardware and different things like that. But the big thing I want to look at here is all this stuff right here, and this is just this is cost from the materials that I had to buy, like metal and some plastics that I got CNC milled, different things like that, because just having 3D printed materials isn't going to hold up very well in this class. So you do need to buy some more expensive materials, and that ends up being about an additional $50 to $60 here just to get all this metal and other parts laser cut or fabricated, whatever. You're going to end up spending a little bit more money. And so that's what we see here down in the final price, is it's ending up being around $60 to $70 more than a plastic Antweight of similar complexity. So really, when it comes to Antweights over plastic Antweights, you're going to end up spending more money on materials. So you could be looking at 50% to even more than that of the cost of a plastic Antweight. So looking back here, I'd say a good cost range for an Antweight is $100 to $300. People do spend more than that, but I'd say more than $300 for just the robot itself is getting pretty expensive. And under $100, you're really saving a lot of money. So if that's your goal, good job. Next is Beetleweight, which is a 3-pound combat robot class. And this is another fun one. It's a little bit more advanced of a weight class because you're going to be spending more money on electronics and materials, and you also have to factor in the more destructive forces that come into play as this weight class is heavier, and you're going to have to do some different design methods just to deal with this heavier weight class. That being said, it's more fun, in my opinion, so if you have already competed with Antweights and you want to move up, I definitely recommend trying a Beetleweight. So we're going to look at my Beetleweight lifter, Jolly Rat 4, which is just a 4-wheel drive lifter. Alright, so here, looking at these motors here, only $7 each. I am using 4 of them, but I'm going to talk a little bit more about this in a second, but this is where I tried to save money on the motors, and it actually came back to bite me a little bit. Jolly Rat 4's drive is not really the best, so I'm working on upgrading those motors. So I definitely recommend you spend a little bit more money to get those good quality drive motors. Other than that, this robot has a lot shorter list of materials than my Antweight, and that actually ends up leading to a lower overall price of just over $150 for this robot. So that is due to a lot of factors. This robot is a lot more simple, so it has a lot less parts, so that in the end just causes the entire thing to be much cheaper than, well, not much cheaper, but slightly cheaper than my Antweight. I'll go over a little bit more about this in a second when I talk about how you can reduce the cost of your combat robot. But overall, for this Antweight robot, pretty cheap for only 150 bucks. So I'd say Jolly Rat is right at that very low side of what a Beetleweight will cost at about 150 bucks. And it just goes up from there. This is a weight class that people really do spend a lot of money on. There's very competitive robots that cost over $1,000 for just a 3-pound robot, which is really a lot. But I'd say a good range is $150 to $400 would be a good kind of starting range for building a Beetleweight. Alright, so now that we've gone over how much my robots cost, I'm going to talk a little bit about how you can save money and how maybe you shouldn't be saving money when you're building your robots. So before you try to save money on your combat robots, make sure you know where to save and where to get the good stuff. So certain parts you should not cheap out on. You should get good quality parts you know are going to be reliable and work well, just because certain parts of the robot, if it's not working at 100%, can lead you to lose a lot of fights and can cause you a lot of frustration, all to save a few bucks, which I don't really think is worth it considering the amount of time that you invest in building a combat robot. You want to make sure you just spend that little bit extra to make sure you're going to get that good performance that you want. But also keep in mind that more money can make a good design much better, so keep that in mind when you're building. But before you spend all your money, remember, it's not pay to win, and if you have lack of experience, lack of design skills, spending a ton of money on the very best parts might be wasted. So if you're like brand new, I highly recommend going with some cheaper options, and as you build up your design experience, you can justify spending that extra money to get the extra performance. But if you're brand new, not really quite sure what you're doing yet, I don't recommend going out and spending a ton of cash on the most expensive parts. Now, here's from my personal experience the best ways you can save money when building your combat robots. So first things first, don't wait until the last minute. This is pretty common in combat robotics. A lot of people will wait until the very last few weeks to start building a robot. I've done this before a few times, and I can say that it's going to end up costing you a lot more money. If you're doing things like rush ordering parts from Send Cut Send, CNC Madness, or even just like buying off-the-shelf parts from McMaster-Carr or even Amazon, that's going to be very, very expensive compared to ordering things from a website like AliExpress, which is a website I strongly recommend you check out. Some people have different opinions about this. There is a lot of junk on AliExpress, so you do kind of need to know what you're looking for in order to get actual good quality parts. But that being said, I do highly recommend AliExpress to save money. Just make sure you're not buying certain things from there unless you are willing to take the risk that they may not work as you want them to. But as far as how waiting till the last minute and AliExpress relate, AliExpress takes much longer to ship. A lot of these websites that have cheaper products are going to take a lot longer to get to you, so you need to make sure you plan ahead and get all your parts ordered well in advance so you can take advantage of that cheaper cost. Another way is to simplify your design. If you want to save money, the best way to do it is to have a simpler design with less unique parts. That's going to cost a lot less. So, for example, like a wedge with a very low part count is going to be much cheaper than something like my overhead shuffling spinner, which has a ton of parts on it and is pretty expensive and has a bunch of different things that need to go into it. So simplifying it can help you save a lot of money. Another thing is brushed motors. As compared to brushless, if you want to do brushless motors, go right ahead, but just know it's going to cost more money to get that system up and running. So if you want to save money, go with brushed motors. They work just fine. You can still be very competitive with them. And then here is a few things I found is a good place to kind of save some money on. And that would be things like hardware, so screws, nuts, bolts, things like that. You can save money on those and not really suffer too many ill effects from that. Another part I found to be where you can save some money on is servos. Even the cheaper ones I found usually work very well, so you can save money there. Things like wire for wiring your robots and connectors you can buy because they're very simple parts and there's really not a whole lot that can be screwed up by buying cheaper ones. And a big one is wheel hubs. I'd highly recommend taking some time to design your own wheel hubs instead of buying things like FingerTech twist hubs, which are very, very expensive for what they are. You can save a ton of money by making some of your own custom parts, 3D printed or otherwise, and that'll save you a lot of money. Another thing is use less expensive materials. So instead of carbon fiber and titanium, maybe go with some 6061 aluminum or things like that if you have the ability to do so. If you want to go for those more expensive materials, by all means, but just realize that you are going to be spending more money to get those. Alright, now worst ways to save money. I'd say a bad way to save money is electronics like ESCs and batteries, just because you want these parts to be very functional and reliable. If they fail, your robot will be dead in the water. So this has happened to me on a couple occasions, so I just highly recommend you spend a little bit more on these parts to get something you know is going to work well. Another thing that is not good to go when it comes to saving money is buying improper materials. For example, on my past version of Overdraft, I used 5052 aluminum when I should have been using 6061 aluminum, which is a stronger and a little bit more expensive type of aluminum. And by using that cheaper material, that cost me fights and a lot of durability. So I definitely recommend buying the proper material, even if it's more expensive. And another thing is motors. These are so critical to the performance of your robot. I just don't recommend cheaping out on these things unless you for sure know that you're still going to be getting a good product. All right, to conclude everything, it's your money and it's your robot. So at the end of the day, buy whatever you want. If you want to buy all the most expensive things, go right ahead. It's your robot. And just make it the best you can with what you're buying. And make sure to always have fun. It's not all about winning. Sometimes you can throw together a cheap robot and have a ton of fun with it. So that's just my advice. I hope you found this interesting in regards to how much my robots cost. I'd love to hear down in the comments below how much you've spent on a robot. Maybe what's the most expensive robot you've built and what's the cheapest robot you've built. I'd love to hear that. I think that's very interesting. Other than that, if you have any questions for me, I'd be very happy to answer them down in the comments. You can also email me. And other than that, I hope you guys have a great rest of your day, and thank you for watching Robot Fight Club.